If we do another example, what volume of carbon dioxide forms, so this is our unknown, forms from the combustion of 5.25 grams of methane, so that's my known, at 101.325 kilopascals and 273 Kelvin. Again, you need to be able to tell by looking at that that is standard temperature and pressure. And we also need a balanced equation here. So we are combusting this methane, or carbon tetrahydride. Start with CH4, and this is combustion of a hydrocarbon. So we're reacting with oxygen to form carbon dioxide plus water. 1 carbon dioxide is enough for methane, but I need 2 molecules of water to cover those 4 hydrogen atoms. And now I have 2 plus 2 is 4 oxygen atoms, so I need 2 oxygen molecules to get 4 oxygen atoms. Now that I have a balanced equation, I'm ready to set up my stoichiometry problem. I'm starting with 5.25 grams of carbon tetrahydride. Now, I'm starting with grams, so it's going to take me 1 step to convert from grams to moles. I have 2 different substances. I've got methane and I've got carbon dioxide. So switching from one substance to another substance takes a second step. Then I want my final answer to be a volume. So it's going to take me a step to convert from moles to volume. So I've got room for 3 conversion factors here. Let me write them down. First, I get rid of grams of carbon tetrahydride and I convert to moles of carbon tetrahydride. 1 mole, if I use the periodic table, has a molar mass of 16.05 grams. Then I get rid of my 1 mole of CH4 because there's a 1 here in the balanced equation, and I'm converting to carbon dioxide, which also has a 1 in front of it in the balanced equation. And then I convert from 1 mole of carbon dioxide to my final volume, which is measured in liters. I have 22.4 liters of carbon dioxide for every 1 mole because I am at STP, standard temperature and pressure. So we've got 3 sig figs limiting the number of sig figs in our final answer. So even though when we do 5.25 times 1 times 1 times 22.4 divided by 16.05 divided by 1 divided by 1, the calculator gives me the answer 7.327103 or something like that, but I want to round off to 3 sig figs. This number is 5 or higher, so I've got 7.33 liters of carbon dioxide. Let's do another example. What mass of iron 3 oxide will be formed from 52 liters of oxygen and excess iron at standard temperature and pressure? So I've got iron, I've got oxygen, and I'm forming iron 3 oxide. Remember, iron 3 oxide is iron with a charge of 3, and oxygen always has a charge of -2, so the final formula is Fe2O3. And I know that I've got 52 liters of oxygen. It says I've got plenty of iron. I've got excess of this, so I don't have to worry about how much iron I have. But I want to know how much mass, how many grams of iron 3 oxide I can make. So when you're converting from one substance to another substance, just the conversion takes 1 step, 1 conversion factor. It's going to take me a conversion factor to get from liters to moles. And then when I convert between substances, that's moles to moles. And it takes another step to convert from moles back to grams. So this is going to be a 3-step process. I'm starting with oxygen, and I have 52 liters of oxygen to start. And then I want to get rid of my liters of oxygen because I'm going to convert to moles of oxygen. And I know that I have 22.4 liters for every 1 mole. Now, I haven't actually balanced this yet. I need to balance with a 3 and a 2, and 2 times 2 is 4, so I need a 4 in front of my iron here. I see that I have 3 moles of oxygen for every 2 moles of iron 3 oxide that I make. And therefore, I can do my final conversion factor where I get rid of moles of Fe2O3 and I bring in the mass. The molar mass of iron 3 oxide is 159.70 grams of Fe2O3. Doing the math, 52 times 1 divided by 22.4 times 2 divided by 3 times 159.70 divided by 1, you get as your final answer 247.1548. However, we can only report our final answer to 2 sig figs. 2 sig figs. Remember, when you round to 2 sig figs in a situation like this, do not tell me the answer is 25. 25 is nowhere near 247. When you round off to the left of the decimal place, it's important to remember that you, no, I need to round up because that number is a 5 or higher. You need a 0 in there as a placeholder. So my answer is 250 grams of Fe2O3 with an answer given to 2 significant figures. Let's do a final example. How many liters of water vapor are formed from 25 liters of oxygen at STP? So we're talking about forming water from oxygen at standard temperature and pressure. Of course, we need some hydrogens as well. So this, we're talking about a synthesis reaction here where we've got hydrogen plus oxygen gas forms water. To balance this equation, I need to have 2 moles of hydrogen gas for every 1 mole of oxygen gas to make 2 moles of water. And in this example, I'm starting with 25 liters of oxygen. And I want to know how many liters of water vapor, so a gas, how many liters of gas I can make in this example. In this example, I'm starting with 25.0 liters of oxygen, and I'm trying to calculate how many liters of water vapor I can create. So I have to convert from liters to moles so that I can use my mole-mole ratio to calculate the number of moles of my unknown, and then I need to use my number of moles to calculate liters. So this is a 3-step process. And if I start with my 25.0 liters of oxygen, I can get rid of my liters of oxygen by using my 22.4 conversion factor is the same as 1 mole of oxygen. Then I can use the mole-mole ratio in my balanced equation to get rid of 1 mole of oxygen because that corresponds to 2 moles of water. And then I can get rid of moles of water because I know that 1 mole of water corresponds to 22.4 liters of oxygen. So 25 times 1 divided by 22.4 times 2 divided by 1 times 22.4 divided by 1. My liters of oxygen cancels out. My moles of oxygen cancels out. My moles of water cancel out. And I'm left with liters of oxygen as my units. And when you do the math, 25 times 2 times 22.4, but divided by 22.4, so you get to 3 sig figs, 50.0 liters of water. I hope this helped.